Happy Happy African Freedom Day.
Thank you. Same to you.
Thanks. So this topic in mathematics, I told you we're going to start doing, we're going to do 4 paper 2 topics that I want you to answer without fail. You're going to make sure you answer these questions extremely well. So I'm going to teach you trigonometry. I'll teach you statistics, linear programming, and another one, maybe quadratic functions. So those 4 topics. Every year, paper 2 math, if you want to pass mathematics, you have to focus on paper 2. And at times, we live in a world where there's a lot of malpractice, and some people will actually have the exact same leakage that's coming exactly. But because they did not grasp certain mathematical principles, they are going to fail to solve that leakage, and they are going to go with the actual leakage in the exam room, and they'll be arrested, etc. So we don't want that. What we want is an exam strategy where you know what you're going to answer, and trigonometry is one of them, a very, very important topic. And how do I identify that this is trigonometry? When you're in an exam room, you're going to see triangles, and the types of triangles that you're going to see are of 2 types. So we can categorize these triangles in 2 types. We have right-angled triangles. A right-angled triangle. And we have got trigonometry of non-right-angled triangles. So every time we're talking about trigonometry, we are looking at the relationship of certain sides of triangles in relation to their angles. How can we use the sides of the triangle and the angle inside the triangle? And certain principles that you have to remember is that a right-angled triangle, so we're going to start off with trigonometry of the right-angled triangle. And at your level, at all level, the trigonometric ratios that we're going to deal with will be sine, cosine, and tan. So these are the 3 trigonometric angles that we're going to deal with in our O-level syllabus. And these usually, they apply in non-right-angled triangles and right-angled triangles. So if you have a right-angled triangle, by the way, first thing that you have to know is the different types of triangles. The different types of triangles. So there are about 3 different types of triangles that ECZ syllabus usually focuses on. The first one is the right angle triangle, where you have a 90-degree angle there. So this is the right angle triangle. The second one is an isosceles triangle, where you have got 2 sides that are equal. If 2 sides are equal, so 1 slash and 1 slash means this side is equal to this side. Sometimes you can have 2 slashes there. So if you have identical number of slashes, it means those sides are equal. So it means this angle is equal to this angle. So if this side, if AB is equal to BC, then this angle here is equal to this angle. So this is an isosceles triangle. Isosceles, something like that. Then the last triangle that you're going to deal with is an equilateral triangle, where all of the sides are equal. So let's say X, Y, Z. So all sides are equal and all angles are equal. And the important thing that you have to know is that all the interior angles in any given triangle add up to 180 degrees. When I say interior angles, I mean the angles that are inside. So if I added this plus this plus this in a right angle triangle, I would get 180 degrees. If I added this angle, and that angle in an isosceles triangle, I'll get 180 degrees. If I added this angle, and that angle in an equilateral triangle, I'll still get 180 degrees. So all the interior angles in any triangle add up to 180 degrees. On that note, let's go into the trigonometry of right angled triangles. So this lecture, we're going to start off with trigonometry of right angled triangles, where we talk about, let me give you a brief outline, where we talk about SOHCAHTOA. After talking about SOHCAHTOA, we're going to move on to non-right angled triangles. Here we're going to do the sine rule and the cosine rule and area of a triangle, and certain scenarios where we are supposed to use the two formulas of area of a triangle. And then we're going to end with a 2019 mathematics paper. So I got, this was question 8 of 2019 paper, where there was a question on trigonometry. And so this is 4, 5, 6, 7, 8. 9, 10, these usually carry 12 marks. So by the end of this, this lecture, you are guaranteed of 8 marks in your examination. And by the way, remember, you already got 5 marks. The 5 marks in paper 2 comes from the quadratic formula. You know, b squared is equal to s, x is equals to minus b plus or minus root of b squared minus 4ac, the whole thing over c, right? Yeah, b squared minus 4ac over c. So that's trigonometric, that quadratic equation carries 5 marks. So today we're going to do the trigonometry that you need so that you can get 8 marks when it comes to a question under trigonometry. So let's move on to the trigonometry of a right angled triangle. So in a right angled triangle, we have got this rule called SOHCAHTOA. SOHCAHTOA. But how do we define SOHCAHTOA? Let me try to draw a right angled triangle properly. Let's see, just inserting lines so that we can have a proper right angled triangle. Use this. Okay, let me extend it a bit. Then let me add another line going downwards. Okay. Okay, that's good enough. So this is a right angle triangle denoted by this 90-degree angle. And let's put another angle there and call it theta. And remember, it won't always be theta. Sometimes the angle will have a name, sometimes the angle won't have a name. Sometimes it can be gamma or alpha or beta. Sometimes it will just be A, B, C. So there will be certain scenarios where the angle is going to have a name and where the angle won't have a name. Sometimes you just have to use the sides and say maybe angle ABC, meaning the angle in between. So let's say this is a right angle triangle with those sides. So you've seen the tip of this angle here. If you follow the tip going this way, you're going to form a side known as the hypotenuse. The hypotenuse. Then if you have this angle here, theta, if you follow it this side, like so, you're going to have something known as the opposite. The opposite. And because this side is closer to this angle and this angle, we will say they are adjacent to the two angles. So we'll call this the adjacent. Adjacent. Have you gotten that?
Yes.
All right. So if you have this tip of this angle, and don't worry, I'm going to send you these notes together with the notes on acids, bases, and salts. I made a PDF so that you can write them in your book, and especially these, yeah, even the acids, bases, and salts, so that you can write them in your book and use the video to study. So this tip here, that's the hypotenuse. You follow it like that. Sorry, this angle here, the tip, you follow it, that's the hypotenuse. If you have this angle there, you follow it to the end, that's the opposite. Then the one that's next to these angles, this side will be the adjacent. Therefore, given SOHCAHTOA, so every time you see a right angle triangle, and maybe they say X, find X given some certain sides, you just have to say, all right, this is most likely trigonometry, and I'll just say SOHCAHTOA. SOHCAHTOA. You have to know how to write this. It should be, you should meditate on this. So you will say sine theta, sine the angle that we named is opposite over hypotenuse. That's sine. Sine theta opposite over hypotenuse. Then cos theta, the name of the angle, is the adjacent side over the hypotenuse. Then tan theta is the opposite over the adjacent. That's it. SOHCAHTOA, very life-saving. And this question usually comes most likely sometimes in paper 1, sometimes in paper 2. It usually comes combined with Pythagoras theorem, because in a right angle triangle, you can not only extract trigonometric ratios, but you can also extract the Pythagoras theorem. So remember this SOHCAHTOA. You know how to find your hypotenuse, how to locate your opposite, how to locate your adjacent side, and know this, how to write this properly by all means. SOHCAHTOA. Know how to write this. So we have to apply what we've learned. It will be a build-up. No wonder these, please watch this video. I'm going to send this video literally immediately after class, because today is African Freedom Day, meaning I don't have a class at 17. So we can talk for as many hours as we want. Immediately I send you this video, find time to study this topic. This topic, paper 2, immediately you open that math paper 2 paper, just go straight to trigonometry and answer it as accurately as possible. So let's try and use SOHCAHTOA to find the value of X. In the first diagram, X is a side, and in the second diagram, X is an angle. So how are we able to do that? So find the value of X. It looks like I'll be at, there is no right angle triangle in the shapes there, but they are all non-right angle triangles. So I have to draw another right angle triangle real quick. Okay, it will be slightly bent, but it's fine. So that I explain properly with a proper diagram. This e-learning, I swear you have to adapt somehow as educators to deliver good quality education in times like this. So that's a right angle triangle. How do we know that it's a right angle triangle? This angle there, and this is side A. You have the calculator nearby.
Yes.
All right, good. This, that's X, and this is 4 centimeters. So every time you see a question like this and they say, all right, let's find X, which is AC, the distance AC, you have to ask yourself, all right, what have we been given? So what is this x that they want us to find? So you follow it there from the tip and you're like, okay, x is the hypotenuse and the angle is this side. So I'm going to follow it like that. And if I follow it, I'll be like, okay, we've been given the opposite, which is 4 centimeters. So we've been given the hypotenuse and we've been given the opposite and our angle there, theta, which is 30 degrees. So you ask yourself from there, okay, you say so, ka, doa. Then you ask yourself, okay, which trigonometric ratio has this information that we've been given in the question? Which trigonometric ratio has the hypotenuse, which is the side that we want to find, which has the opposite and theta? So which trigonometric ratio can we use that has both hypotenuse and the opposite? Sine, right? Hello, Fabi. Sine,
Hello.
right? We can use sine. Let me go back. So this triangle here, we've been taught to find the value of x. So we have to know what we've been given. We followed this tip there to locate x, and we found out that, all right, x is the hypotenuse. So we have the hypotenuse. Then we followed this angle there to the opposite, and we said 4 centimeters, we have the opposite. And we have this angle there, we've called it theta. So we have got theta, we have got opposite, and we have got the hypotenuse. And they want us to find the hypotenuse, which is x. Then we ask ourselves, we say, so katoa, which trigonometric ratio has opposite and hypotenuse between sine theta, cos theta, or tan theta? It's sine, right?
Yes.
So we're going to say sine theta. Sine theta is opposite over the hypotenuse. Then from there, we'll just get the information from this question and start substituting. The theta there is 30 degrees. So we're going to say sine 30 degrees is equal to the opposite. We found the opposite as 4 centimeters because we followed that angle. So that's 40 over the hypotenuse. What's the hypotenuse? X. That's the x that we want to find. So where there is hypotenuse, we're going to substitute it with x. This is why I need to send you this video as soon as possible so that you can practice with the notes. So this now becomes an algebraic expression. So I want to make x the subject of the formula so that I can solve this equation. So I'm going to make this sine 30 degrees a fraction over 1, and I'm going to cross multiply. If we multiply x times sine 30, we're going to get x sine 30 degrees is equal to 40 degrees. So the only thing that we have to do now is what's the value of sine 30? So we go on our calculator. I couldn't find my calculator. No wonder I told you have a calculator nearby. I'm using the phone calculator and I don't trust it that much. So you say sine 30 degrees. What's sine 30 degrees? Hmm?
0.4.
Okay, that's the opposite and the hypotenuse. Yeah, sure, it's 0.4. It's the opposite.
0.45.
0.45.
3.
Oh, all right. See, My calculator is in a radian mode, so let me convert it to degrees and say sine 30. Can we round it off to 0 0.5? Sorry, tell me your answer.
0.45.
All right, so we'll say x 0.45. Remember, we're still multiplying, but we've only found the value of sine 30. So sine 30 is 0.45, so it's 0.45 multiplied by x. So equivalent to 40 degrees. So we just divide both sides by 0.45 over 0.45. That cancels. So on your calculator, clear it, and then say 40 divided by 0.45.
Eight.
88.
Point
88.8.
88.
Sine 30. Oh, I see my mistake. Why didn't you tell me? Why was I writing 40 centimeters? This is 4. It's 4 centimeters. I put in 40 all the way. My goodness. Let's do it again as a form of rotation. So this has to be 4 centimeters, not 40 degrees. My goodness. So divide 4 by 0 0.45. So say 4 divided by 0 0.45. Yeah, much better. What's your answer?
8.
8.8.
8889.
Recurring, right? So we can just round it off to one decimal place and say x is equal to 9 centimeters. So that's how you use a trigonometric function. Don't put 40 degrees there. It's 4 centimeters. So that's how we use trigonometry in terms of a right angled triangle. Step 1, you're going to see the question. Oh, there's another question there. Let's solve question 2. I didn't see it. This one is where we have to use inverse of sine. I'm going to show you this very shortly. But it's the exact same procedure. Step 1, you identify that you have a right angle triangle. Then you list the things that have been given in the question. Have you been given the hypotenuse, the opposite, or the adjacent? And then you say SOHCAHTOA, and then you substitute and solve the given equation. So let's check this question out. Again, I have to quickly draw a triangle because it's e-learning. But I won't struggle with the rest because at least there's a non-right angle triangle. The only difficult part is drawing a right angle triangle. There's no right angle triangle in this question. In Microsoft OneNote. Oh, yeah, there we are. Okay. So let's draw this. So this is 90 degrees there. This is 5 centimeters. This is 4 centimeters. And this is x degrees there. So again, you tell yourself, all right, so this is a right angle triangle. You follow the tip there, you go like so. Meaning this side is the hypotenuse, meaning we have the hypotenuse. We follow it this side, this angle, we go like that. Meaning this side is the opposite. And what do we want? We want this angle there, theta. So what do we have? We have the hypotenuse, which is 5 centimeters. We have the opposite, which is 4 centimeters. And we have got theta there, which is x degrees. Then step 2, you say SOHCAHTOA. Then you ask yourself, which among these three trigonometric ratios has hypotenuse and opposite? Or it's sine again. So sine has both hypotenuse and the opposite. So we're going to use sine again. We'll say sine theta is equal to opposite over hypotenuse. Then we just substitute. The the theta there is x degrees, the one that they want us to find, x degrees, equal to, the opposite is 4, over the hypotenuse is 5, like so. By the way, this step is very important. You're going to see this step, especially when we do the sine rule, even the cosine rule. So get your calculator and say, start with 4. Say 4 divided by 5.
Zero 0.8.
All right, excellent. So that is 0.8. So normally, when we have an equation like this, to find the value of x, we usually divide both sides by something, right? So we can't divide both sides by sine. By sine what? It doesn't make sense, right? In the previous one, it made sense because we said sine 30, we had a value. But this time, we do not know the value of sine. So how do we make x the subject of the formula then? We're going to use something known as inverse of sine. And this works with all trigonometric ratios, whether it's tan or cosine. So you're going to say x degrees is the inverse of sine 0.8. If it was like this, tan x degrees is equal to 0.8, it would have been x degrees is equal to the inverse of tan 0.8. If it was like this, cos x degrees is equal to 0.8, would have said x degrees is the inverse of cosine 0.8. So how are we going to do this? So clear your calculator. You've cleared your calculator?
Yes.
So press shift. You've pressed shift.
Okay.
After pressing shift, so let me write the instructions here. So press shift. Then you don't put this plus. It's just saying, so it's press shift. Then plus, don't put plus. Okay, let me not say plus. Step 1, press shift, then sine 0.8. So press shift, then press sine, then put 0.8 on your calculator.
Okay.
Now, what are you getting? So you press shift, then you put sine. If you press shift, then sine, it's going to look like this, inverse of sine on your calculator. It will look something like this. Then you punch in the 0.8, then you press equals.
59.03.
59.03. Yeah, sure.
34.
Yes.
Yes. 34. 34.
Inverse 0.8. Here I'm getting 53 degrees. So press shift, sine. Then punch in 0.8.
59.
59 degrees. Here on my end, I'm getting 53 degrees. It has to be 53 degrees, but maybe again, I am using the phone calculator. Maybe your answer is correct. So I'll put 59 or 53 degrees. I think it has to be 53 degrees, but I don't trust my phone calculator. Can you clear the calculator once more time? Just clear everything.
Okay.
Then we do it together.
Mm.
So press shift. You've pressed.
Yes.
Then sign. You've pressed sign.
Yes.
Then open brackets. There's a sign with brackets.
Mm-hmm.
Put 0.8. Then close the brackets. Then press equals.
The answer is the same.
It's still 59.
Yes.
All right, then we're going to go with your answer as 59 degrees, which, so that's how you find the angle there. So the angle is 59 degrees, like so. So this is how you use trigonometry for right angled triangles. You just have to identify uh, where your opposite is, where your hypotenuse is, and where your adjacent side is. Is that all right?
Yes.
Okay, so let's move on to the cosine rule. Oh, we moved on to the cosine. I have to start off with the sine rule. Uh-oh. I didn't add the notes for the sine rule. Let me just add them here. So let's move on to the sine rule. I can still teach it here. So these will be your notes for the sine rule, because I didn't indicate it there. I can. Cosine rule, area, or maybe the notes are above. Yeah, here are the notes. I would have been surprised. So let's now talk about non-right angle triangles. Let me just wrap the board in a digital era, I suppose. So that we talk about sine rule and how are you supposed to identify the sine rule in the exam, or the cosine rule in the exam. Very, very simple way to identify this in the exam. So non-right angle triangles, they can either bring an isosceles triangle, an equilateral triangle, and at least Microsoft OneNote has a non-right angle triangle. So from here, I can just do this. Let me just rub it. I can do this. Move it here. Okay. So let's draw this triangle. We have capital letter A there, capital letter B, and capital letter C. We have an angle there, we have an angle there, and we have an angle there. So this angle there can also be called big letter A. This angle here, which is on B, because it's on B, it's big letter B. This angle here on C, because it's right at the edge of C, it's called big letter C. So we can name the angles as angle A, angle B, and angle C. And if you follow this side there, you can say this is small letter C. You follow this side downwards, you say this is small letter A. And you follow this side, you say this is small letter B. Have you gotten that?
Yes.
I've just followed their opposite sides. So because I followed their opposite sides, the sine rule states that their ratios are the same. The ratio of the sides in relation to the angle is the same. So this A here comes from this side. So A over sine A, where it's come from. is the same as, let's go to B, this small letter B, this side where B is, small letter B, over where the sign B comes from, the angle, is equivalent to, we go this side, small letter C, where the big angle comes from, sign C, like so. Is that hard?
No.
We just follow this side. This triangle B has a side small letter B. This side C has a side small letter C. This angle A has a side small letter A. How are you going to identify that? In an exam, we are supposed to use the sine rule. You are going to have more than two angles. More than two angles. So if you see a triangle, because you know you're going to deal with trigonometry in your paper 2. If you see a triangle which has more than two angles inside, then you just say, all right, I have to use the sine rule. For example, this 2019 paper, two angles there, 40 degrees, 125 degrees. Something has to tell you that, all right, in order for me to find the distance BC, I have to use the sine rule and not the cosine rule. So cosine rule, 5 marks, sine rule, usually 5 marks also, or 4 marks. Very, very important and very, very easy to use once you just know it. Immediately you state it, you get 1 mark. You substitute, you get another mark. You solve the question, you show your method of solving, you get another mark. You show your final answer, you get another mark. Just by following sides. Trigonometry is so simple because you just follow sides. You know, at times questions can look intimidating because, oh my God, we have a lot of sides, etc. How am I supposed to find the answer? But it's very, very easy. So let's do a practice question of the sine rule. Let me insert the triangle. Okay, it's good enough. So calculate angle BAC. Calculate angle. So we're trying to find angle BAC, this angle there in between. Given that this side is 13 centimeters, that's A, that's X degrees, and this is 97 degrees. That's side B, that's side C, and this is 7 centimeters. So they want us to calculate this angle, angle BAC. Oh, I drew it the wrong way. Angle BAC is this angle here. Would have made another mistake. That's the angle there. So when I send you the notes, put the angle. Oh, I can just do this. Yeah. Put the angle properly. It's supposed to be this angle there. Angle BAC. So X has to be here and not there. So let's try to find this angle there labeled X. Again, you're in an exam and you see, all right, this is a non-right angle triangle, and I have more than one angle. I have two angles. Because I have two angles inside this triangle, okay, I have to use the sine rule. How do I use the sine rule? You follow this side there. At times it can be X, Y, Z, whichever it is. You just follow this capital letter there to this side, and you say, okay, this is small letter A. You follow this side there, although we haven't been given this angle. If you want, you can follow it. You say, okay, this is B. You follow this side and you say, okay, this is small letter C. Then you tell yourself, all right, small letter A over sine A is equal to small letter B over sine B is equal to small letter C over sine C. Then you start to substitute. Okay, what do we have here? Small letter A is 7 over sine x, the one that they want us to find, this BAC angle, is equal to, all right, what is small letter b? Okay, small letter b is this side here, which is AC. There's nothing there, but we'll just include it. AC over sine b. We haven't been given anything there also. What is small letter c? 13 centimeters over what is capital letter C? 97 over sine 97 degrees. Okay, so from here, because everything is equal, I can use this one and this one to find the answer so that I can just cross multiply. This one is not working, is not serving any function. So I'm going to ignore this one. So I'm just going to, because they are all equal. So I'm just going to say 7 over sine, so we ignore this one. 7 over sine x is equal to 13 over sine 97 degrees, like so, because everything is equal. So now I can, this is now an algebraic expression. I can just cross multiply and find the answer. So I'm going to cross multiply and say 13 times sine x, it will be 13 sine x is equal to, so on your calculator, we have to find the value of sine 97 and multiply it with 7. So on your calculator, you say sine 97, then you multiply, after finding the answer, you multiply it by 7. What are you getting? So punch sine 97, then you say equals, then you say times 7.
6.9.
All right, excellent. But we're going to say 6.9478. At least leave 4 decimal places. You only round off the final answer to maybe 2 decimal places or 2 significant figures. So because you want to find an accurate answer, you leave it at least to 4 decimal places. So you clear your calculator. So here we're dividing both sides by 13. So we divide both sides by 13. We cancel that. So we're going to say sine x is equal to, so on your calculator, say 6.9478. Then you divide it by 13. What are we getting?
0.5.
Yes. 5344. We'll leave it.
4.
It's okay, right?
Yes.
So again, you've seen every time we're finding an angle, in trigonometry, we have to use inverse of sine because we can't say divide both sides by sine. What are you dividing sine by, or tan by, or cosine by? So what we're going to use is inverse of sine. So you have to show the examiner, by the way, that x is equal to the inverse of sine 0.5344. Therefore, x is equal to, so again on your calculator, you press shift, then you plug in, you press shift, then sine, then you plug in 0.5344. What are we getting?
35.89.
35.89. How come our calculators are disagreeing? So my answer is 32.30 degrees. Again, maybe it's because I'm using the phone calculator, but this makes sense. So our angle there is 35 degrees or 36 degrees if you want to round it off. Yeah, we can just say 36 degrees because there are, one of the angles here has been given in terms of no decimal place, 97 degrees. So we'll just round it off. So round it off to 36 degrees. So this is how we use the sine rule. Very, very easy. It's just sides and ratios. As long as you are able to identify that, okay, so how, the first question you ask yourself, you've seen a non-right angle triangle in an exam room, paper 2 math. How do you identify that? Am I supposed to use the sine rule or the cosine rule? What do you do? If you see an angle that has two, if you see a triangle, sorry, if you see a triangle that has two angles inside it or more, your brain has to say, all right, this is the sine rule, and I'm going to say this angle over that, this side over that side over that. And the question becomes extremely, extremely easy. So this is how we use the sine rule. So let's now move on to the cosine rule, how we are supposed to identify the cosine rule in an exam, and how are we supposed to use it. So I'll be very upset if you don't watch this video. You have to watch this video, you revise it, because this is a lifesaver. Once I teach you this, you're going to get your 8 marks very easily in the exam. Then once we learn how to do statistics, you know how to find variance, standard deviation, and how to plot the cumulative frequency table, that would be another 8 marks. When we go to, you know, graphing the trigonometric function, that would be another 8 marks. When we do linear programming, you know, a farmer has this many chickens, he wants to do this, not he should buy less than 5 chickens or not more than 10 cows, and then you shed the region that defines this inequality. At least linear programming is also another easy topic. That would be another 8 marks. You forget about transformations, forget about earth geometry. You just have to master 4 topics, and you go into math paper 2 and say, I am going to answer those. When it comes to paper 1, just try your best, because you answer all questions. So just try your very best to answer as many questions as you answer what you know first. All right, so let's go back to the cosine rule. Let me insert a triangle. So we're going to start by how are you going to identify whether you're using how to use the cosine rule in the exam. So that's A, B, C. Remember, it won't always be A, B, C. Sometimes it can be X, Y, Z, etc. That angle there, that angle there, and that angle there. If we follow this side, this would be small letter A. If we follow this side, this would be small letter B. If we follow this side, this would be small letter C. So please, let me highlight this in purple. How do you identify that you are using the cosine rule in an exam? You are going to see one angle. You're going to see 2 given sides. Every time in the exam room, you're going to have 2 given sides and an angle in between. You're going to only have one angle on that triangle, but you're going to have 2 given sides. That's how you tell your brain that, okay, here we're using the cosine rule. So let's start off with this part here at A. So at A there, I've been given an angle in between, which is A, and 2 given sides, which is this side there, which is C, and this side there, which is B. So 2 given sides, side AC, which is represented by this small letter C, and side AC, which is represented by this small letter B. So 2 given sides and an angle in between. So where this angle A is, I can define a cosine rule right there. How do I do that? I follow it like that. A squared A squared is equal to, then you go to the two given sides. C squared plus B squared minus 2, you multiply them, CB, then you say cos A, where the angle has come from. So from here, you define cosine rule from this side. What if the angle is this side? So let's define cosine rule based off the B side. So we have got a given angle. In an example, you've noticed that, okay, you've been given one angle there and two given sides for B, this side and that side. Therefore, we can define the cosine rule based off this given angle B. How do we do that? We'll just say B squared, this side there, B squared is equal to the two given sides, C squared plus A squared minus 2C multiplied by A cos B, where the angle has come from. Let's go where there is C. Let's define the cosine rule at this point C. So we have got this angle here, one angle and two given sides. So for C there, the given sides are this side AC and BC, denoted by small letter b and small letter a. So we can define the cosine rule there by saying, we start off with like a small letter, C squared. C squared is equal to the two given sides, A squared plus B squared minus 2, you multiply them, AB cos where the angle has come from. You have to meditate on this video. You have to watch this video at least 3 times. You go through this topic. So that's how you identify the cosine rule. You are always going to be given one angle, and that angle will have two given sides. Every time, they will not change this every time. If it's the sine rule, you're going to have at least 2 angles. If it's the cosine rule, you're going to have a triangle which has got 1 angle inside and 2 given sides all the time. Let's do a practice question so that you see this, this in action. And we're going to do 2 trigonometric questions because this past paper shows how to use sine with the exam. When we meet for math, next time we're going to start a new topic, but before we start a new topic, we're going to look at another paper 2 question on trigonometry. So we have got this question. It says, calculate the side AC correct to 2 decimal places. And these questions usually carry 5 marks. You can't do all this work for 2 marks. So this carries a lot of marks. 5 marks is a lot. 5 marks is it can make a whole difference between someone getting a credit and a satisfactory, or someone getting an unsatisfactory or a satisfactory. So remember, you need a credit of 6 or 5. These things are extremely important. So we have got a question there. Given this triangle, it's a non-right angle triangle, ABC, and we have got 61.5 degrees there. Here we have got 45 degrees, and here we have got 60 degrees. Like I always said, or like I said, for cosine rule, you are going to have 2 given sides and an angle in between. Can you see the 2 given sides? We've got this side there, BA, and this side there, BC, and 1 angle in between. Can you see that? Hello, Fabi, can you see that? Fabi? Oh my, oh crap, let me, I haven't noticed that maybe your network has paused. Let me pause. All right, so Have you seen what I was telling you? This question here has got one angle there, 61.5 degrees, and two given sides. So therefore, your brain in the exam room has to tell you that, okay, here I am using the cosine rule. This will never change. ECZ will never change this. If you just see one angle and two given sides, the question is telling you to use the cosine rule about this point. So we have to use the cosine rule about this point. So here's how we're going to use it. So you follow this same point there, that would be small letter b, like so. And this side here, if you follow it, this would be small letter c. And this side, if you follow it there, this would be small letter a. Are we together?
Yes.
Yes? We're together?
Yes.
All right, good. So I followed this side there. I said this is small letter b. I followed this side there. I said that's small letter c. I followed this side there and I said this is small letter a. So we can define the cosine rule about point B. How do we do that? We said b squared is equal to one side there, a squared, plus the other side, c squared, minus 2ac, we multiply them, then we say cos b, where the angle comes from. So we've defined the cosine rule here. B squared, the small one, then the two sides, a squared plus c squared minus 2, we just multiply them ac, cos b. So we have to be very careful at this point here, because sometimes the value of cos any angle, it can give us a positive, sometimes it can give us a negative. So this part that I've highlighted, sometimes the final answer is going to be positive, meaning we're going to add. Sometimes it's going to be negative, meaning we're going to subtract. And have you noticed that this B here is represented by AC? So keep in mind that B is actually AC, which is the side that they want. Calculate AC. So AC is this side there, where we're defining the cosine rule, which is B. So B squared is equal to A squared plus C squared minus 2AC cos B. Or if you wanted, you would have started with C squared plus A squared, because you know, 1 plus 2 is the same as 2 plus 1, commutative rule. And 2 times 3 is the same as 3 times 2, it's the same thing. So you can start with whichever. So from here, we just substitute now. So we're substituting. So B squared is the side that they want us to find. B squared is AC. So B is AC. So we're going to substitute where there is B, we're going to plug in AC. So we're going to say AC is B, but there's a square there. So we're going to say AC squared is equal to, what is A? A is 60. So we're going to say 60 squared plus C is 45. We'll say 45 squared minus 2, open brackets, A times C, it's 45 times 60, cos B, which is 61. Let me just write it properly. 2 open brackets, 60 times 45, close brackets, cos 61.5 degrees, like so. So all we have to do now is substitute. We'll say, oh, is now do the arithmetic. AC squared is, so on your calculator, you can say 60 times 60. So we say 60 Or you can just say 60 squared, it's fine, but I'm using a phone, so you can just say 60 squared or 60 times 60. You're going to get 3,600.
600.
Okay, where's my, okay. 3,600 plus 45 times 45. Now you getting something like 2025, 2025.
Yes.
Okay. Then now here we have to be careful here, extremely careful. The first thing that you have to do is it's best you find what cos 61.5 degrees is first, because sometimes it can be a negative, sometimes it can be a positive. So work out what cos 61.5 is. So you go to your calculator and you say cos 61.5. It's a positive.
Wait. Let's get started.
61.5. This one here, cosine 61.5.
Negative 0.
Negative 0.
0.99.
Negative 0.99. Okay, I suppose I have to trust your answer. This calculator is giving me, possibly giving me wrong answers. So yes, you are saying negative 0.99.
Yes.
All right, so multiply that by 45. So just say answer multiplied by 45, multiplied by 60, multiplied by -2. So the answer will be positive.
Multiplied by what?
Multiplied by 45, multiplied by 60, multiplied by -2. This part here.
Repeat again.
All right, so we are saying, first of all, we said cosine. Anyway, let's first solve, oh no, we have to solve this. So step one, we say cos. I have to put this in degree. So we say cos 61.5, close brackets. Okay, let me first solve it here. Multiplied by, I just got the answer sheet so that I see whether it's by calculator or your calculator. So multiplied by 45, multiplied by 60, multiplied by 2. 2,576. All right, let me solve it. It's your calculator. I think you have to say shift. You have to reset your calculator so that it should be giving you proper answers. Okay, I'll show you how to reset your calculator. I'll send instructions via WhatsApp. So step one, you multiply this part. Where's my, okay. You multiply this whole part here. So I recommend you first start by saying cos 61.5 After saying cos 61.5, you find the answer, then you multiply it by 45, then you multiply it by 60, then you multiply it by -2. So there our answer would be -2,000, -2,576.657, at least 3 or 4 decimal places. Then all we have to do now is add this part here, which is 3,600 plus 2025. You can help me with that. The only problem with your calculator is the trigonometric values. So add 3,600 plus 2025.
55, 52.
All right, yeah, that's correct. Something like this.
Yes.
All right. So minus 2,576.657. Subtract these two for me. 5625 minus 2,576.657.
It's 56, 52.
56.
52.
Hold on. Let me add it here. 3,600 plus 2025. It's 5625. This has 2 zeros. So try adding it again. 3,600 plus 2025 plus 2025. That would be 5. That would be 2. That would be 6, 3, 4, 5. Yeah.
Okay.
Okay. Then subtract it with 2,576.657. Subtract it with this value here, 2,576.657. What
30.
has to be something like this.
30, 48.43.
343. We'll leave it like that. All right. So AC squared. So you've seen this AC squared. To make AC the subject of the formula, we're going to square root both sides such that AC will be left alone. So just say square root. On your calculator, just put square root and equal to. It will say square root the answer.
55.2.
Yes, yes, exactly. So our value of AC is 55.2. Well, 2 decimal places. Give your answer to 2 decimal places, something like that. So 55.21 centimeters is our final answer. So how do we identify in the exam room that we have to use cosine rule? You will always have one angle inside and 2 given sides. Then you just define your trigonometric angle. So this is b squared is equal to a squared plus c squared minus 2ac cosine the angle there, cosine b. Then you just substitute. After you substitute, you have to be very careful when calculating, extremely careful until you find your final answer. So let's now just talk a little bit about area and the 2 formulas that you have to use for area. Then we go to the exam question, then we call it a day. So for area of a triangle, you have to use 2 formulas, extremely important because this comes every year in your exam. So for area, it's exactly the same as the cosine rule. but it, instead of using the cosine rule, you just put sine there. So if you have a triangle like that, a non-right angle triangle, that would be A, B, C. That would be angle A, angle B, and angle C. This is small letter A, this is small letter B, this is small letter C. So exactly with the cosine rule, area, you are going to always have two given sides and an angle in between. So if I want to find the area, if I had this angle and two given sides, my area would be area is equal to half A times C sine the angle, sine B. If I had this side only, this angle, and two given sides, my area would be, area is half CB sine A, where it's come from. If I had only this angle here and two given sides, my area formula would be area is half AB sine C. So exactly the same. You're going to have one angle with two given sides. And then another scenario, this one is extremely important. Every time in trigonometry, you will always be required to find the shortest distance. Calculate the shortest distance to the town, something, 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 something. You have to use this formula for shortest distance. So step one, you use the first formula to find the area. And then after you find the area, you use this formula, half base times height. So the shortest distance will always be the height, which is from the apex of this triangle, the tip, going downwards to the base. So this will be the height denoted by H, and this will be the base denoted by B. So your area will be half base times height. You use this formula in the exam to find the shortest distance. To find the shortest distance. That's the function of this formula, half base times height, and height, this height here, let me even put it in this height will be the shortest distance. So in short, every time the question says calculate shortest distance, you are going to first find area using half AB sine theta, and then you substitute for height. So you're going to have a base. Immediately you have a base and area, you can find the height. The height is going to be the shortest distance. So this marks the end of our trigonometry class, but not necessarily the end, because we have to solve this. We have to solve this question here. Okay. To expand it a bit. I don't know if you, can you see the question?
No.
You can't see, can you see the question?
Yes.
All right, it says in triangle ABC below, we have got this side here, AC, this side AC, which is 200 and, it's 27.5 kilometers. And you have got this angle here, 125, this angle, which is 40 degrees. And the first question is saying calculate the distance BC. So we want to calculate this distance here, BC. So how do you calculate this distance, BC? You are in an exam room and you found this question here. Are you going to use the sine rule or the cosine rule?
Hmm?
Are you going to use the sine rule or the cosine rule?
Sine rule.
Yes. Yes. Mwapasa math. Why? Because you have got more than, you have got two angles there. So what you're going to do, this is capital letter A. Or maybe can I draw this triangle? Yeah, I can draw it. Let me try drawing it so that we can solve it this side. Okay. So I don't know, this triangle looks something like it has got this side, which is like long. Then it has got this side, which is a little bit shorter. Then it has got this side, which is a bit longer, like so. Something like that. So here, this side is, I think this is 125 degrees, 125 degrees. Then this is 40 degrees. And they are saying this is B, that is A, and that is C. And this is 27.5 degrees, 27.5 kilometers. And they want us to find this side here, BC. So what we're going to do, this is capital letter A. We're going to follow it like that. That will be small letter A. Then we're going to follow this side like that. That would be small letter C. We have to find this angle here. We have got no choice because we've been given this 27.5 degrees. So I'm going to go like that to small letter B. Then we're going to state our sign rule. We're going to say A over sine A is equal to B over sine B is equal to C over sine C. Then we start to substitute. A here, A is this side BC they want us to find, right? Calculate BC, so we're going to say BC over sine A, which is 125. Sine 125 is equal to B, with B is 27.5 kilometers, 27.5 over sine B, we're going to find that angle, is equal to C, which is this side BA, BA over sine C, or over sine 40, over sine 40. So from here, we have to choose what to work with. We cannot find this side. It will be very difficult. So we're not going to use this one. So we're going to ignore this. We're going to work only with this. How? We can find this sine B. Remember, in the first part of the lecture, I told you that the interior angles add up to 180 degrees. So if I add 40 plus 125 plus this angle B, I have to get 180 degrees. So this angle there, B degrees, want to find this one here, B, plus 40 degrees plus 125 has to give us 180 degrees. So let's solve this. Add for me 40 plus 125. So you say 40 plus 125.
165.
Yes, so plus 165 is equal to 180. This crosses over, so B becomes 180 minus 165. So our B degrees, so say 180 minus 165. $15 degrees.
Wait.
180 minus 165.
15.
15, right? Okay, excellent. So meaning this is 15 degrees. So here where there's sine B, we're putting 15 degrees. So we're saying BC over sine 125 is equal to 27.5 over sine 15 degrees. And they want us to find BC. So we've used the sine rule. So here it will be easier for us to now cross multiply. So we're going to start off with, say, sine 15. Yeah, your calculator has trouble. Let me solve it. So I'm going to say sine 15 equals, then so sine 15 is 0.5882. So if I cross multiply sine 15 multiplied by BC, it would be 0.2588 BC. So I went on the calculator and patched in sine 15. I found 0.2588 multiplied by BC is equal to sine 125 multiplied by 27.5. So always start with the trigonometric angles. So you say sine 125 like so. Then you multiply it by 27.5. You are going to get 22.5267. Then you divide both sides by 0.258 over 0.258. That cancels. BC will be 22.5267 divided by 0.258. We're getting 87 centimeters. So 87 kilometers, 87 kilometers. I'm rounding off to just no decimal places because all these answers, oh wait, it's one decimal place, there's 27.5. So I'm going to say 87.3 kilometers. So our BC is 87.3 kilometers. So we'll say 87.3 kilometers. I'll send you these notes. You have to revise all this with the video. This video will be long, so it will be long. Prepare your bundles. So we found this side. So next step is just us calculating area, which will be very easy to do. Extremely easy for us to do because, again, this is the beauty of trigonometry. We can calculate, so question 2 says the area of the triangle. We have got this side here, which we've just calculated, 87.3 kilometers, and this side here, which is 27.5 kilometers, and an angle in between. Isn't that just nice?
Yes.
So the only thing that we have to do now is just say area is half this side AB sine 40 degrees. Then we just substitute. We say half multiplied by A is 87.3 multiplied by B, which is 27.5 multiplied by sine 40. Again, I recommend that you first start off with finding the value of sine. So you say sine 40 multiplied by 87.3, then you have it, you say divided by 2. You're going to get your area as 771.59 square kilometers. So our area is 771.59 kilometers, square kilometers. So we've gotten 4, we've gotten 6, which is extremely good. We've gotten 6 marks out of 12. Remember, paper 2 aim to at least get half of the questions. If a question carries 12 marks, get half. That would be good enough. So this is the area. Then again, I told you, look at the next question. It says, the shortest distance A to BC. The shortest distance A, the shortest distance A. So we're going to follow this A to BC. That's the shortest distance that they want, again, which is height. Let me, oops. Let me draw it here so that you see it. Just so that you see it, then I'll go back to calculating. Okay, I'll actually calculate it here. Can you see clearly?
Yes.
Right, so this part was 87.3.
3
Yeah,
kilometer.
Right? And then we have our area. So the question is saying calculate the shortest distance A from BC. So A at the tip. So you where it says A, if they said B, you go at the tip. If they said C, you go at the tip. So I'm going at the tip, their shortest distance A, then we're going to where they are saying to BC, to the base. So that becomes height, like I told you. So what formula are you supposed to use every time they say shortest distance? You say area is half base times height.
B.
Yes, BH, right? Excellent. So the
Yes.
area, we calculated it. Where there is area, we are substituting it with 771.59 is equal to half. The base is this thing here, 87.3, where they said BC, that's the base. So multiplied by 87.3, multiplied by the height which we want to find. So this will be 771.59 is equal to 1 times 87.3 times height. It would be, so it's like I'm making everything a fraction over 1. And then I'm saying 87.3h. So I've multiplied h with 87 with 1, giving us 87.3h. Then I'm multiplying 2 times 1 times 1, which will just be 2. Then from here, I can cross multiply and say 87.3h is equal to 2 times the area. So I'll say 771.59 multiplied by 2. That would be 1543.18. Then, so you have to do all these calculations on your own and compare them with my answers in case I make mistakes. So divide both sides, this cancels. Our height will be, which is the shortest distance. Height will always be the shortest distance. Our height will be, let's divide 1543.18 divided by 87.3. We are getting 17, which is a good short distance. 17.7 kilometers. So that's our shortest distance. Our shortest distance there is 17.7 kilometers. So how many marks have we gotten? 8. So far 8 out of 12. So 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is good. It's extremely good. You're going to encounter questions where you have to solve trigonometric equations, like solve the equation 13 cos theta is equal to 5 for this domain. Forget about these questions. I want you to focus on getting these 8 marks. Whether you're using your cosine rule, whether you're using your sine rule, make sure you get these marks without fail. And because ECZ, they are good people, they'll usually just also give you another simple question down there so that you can get 8, 9, 10. So let's try and solve this question there. It looks a bit, it's like a deceiver because it looks a little bit complex, but it's not that complex. Let's try and answer this question, the last one, because at least we've gotten 8 marks. Let's see if we can make it 10. So we have to simplify 2x squared minus 18 over x plus 3. So how do we simplify this? The only thing that we have to do here is factorize this. We factorize. So how do we factorize? We look for a common factor. 2 can go into both 2 and 18. So the common factor is 2 there. Then we divide the entire expression by 2. So if we divide the entire expression by 2, we're going to get x squared. Remember, the 2 will cancel. Minus 2, 4, 6, 8, 10, 12. That would be 8. Huh? That would be 8. Right?
Yes.
Over x plus 3. We do not want this square, so we're going to use the difference of 2 squares. So the difference of 2 squares will be 2. We open brackets like so. And we say there will be an x there plus the square root of 8 is what? 4?
4.
Is 18. That's 18. We say 18 divided by 2. Oh yeah, sorry, I made a mistake. 18 divided by 2 is 9. I knew I made a mistake somewhere. Those, I would have embarrassed myself. So this is minus 9. So 2 divided by 2, it's 2. So the 2 cancels. Then 2 into 18, that cancels, it's 9. So it's 9. 2 into 18, it's 9. So remember the mistakes that I make at times. So from here, we're going to use the difference of 2 squares. We're going to say this is over x plus 3. So the difference of 2 squares is something like that, minus. So what's the square root of 9? The square root of 9 is
3.
Right?
3.
Excellent. So we'll plug in the 3 there. So that's the difference of 2 squares. Then you would find that all this is multiplication. So we're going to just cancel this part. Then we're going to be left with our answer will be 2 multiplied by x minus 3 as the final answer, because this x plus 3 and this x plus 3 will cancel. We'll be left with 2 multiplied by x minus 3. We've simplified. We've gotten 10 out of 12 just through trigonometry. Remember this question here, as long as they just want you to factorize the numerator and then cancel out. So what did we do? There's a common factor of 2 there. So we put the 2 outside and divide the entire expression by 2. 2 into 2, the 2 cancels, we will be left with x squared. 2 into 18, it's 9. We don't want this square here, so we can use the difference of 2 squares. We put one x there, we put one x, we put a plus, we put a minus. Then we say, what's the square root of 3? Or what's the square root of 9? It can either be 3 or negative 3. Then we just cancel out these, because there's an x plus 3 there and an x plus 3, it cancels. What are we left with? 2 multiplied by x minus 3, which is this. So that's trigonometry. You have to watch this video. I'm going to let me send this video immediately so that it reaches you. You can go have supper. Let's rest. I'll see you tomorrow. We revise a practical.
Okay.
All right.